All right, so here's our last example, and this is a doozy. This is a really, really doozy. So with it, we're going to actually find everything for this, and we're going to graph it out. We have to graph it out by finding your vertical asymptote, your horizontal asymptotes. If there's a slant asymptote, which doesn't happen here, we will find the slant asymptote if they did. There's actually a place for a hole in the graph where we will actually work on that part here, and we'll talk about that. And then we'll go ahead and go from there. All right, so with this, let's go ahead and start off with our vertical asymptotes. And again, in this part, I remember back in class and stuff, we talked about when we did vertical asymptotes, we talked about it could actually be a hole in the graph also, or not a hole in also, but it could be a vertical asymptote or a hole. But it can kind of, vertical asymptote can actually be like disguised, or a hole can be disguised as a vertical asymptote. So a hole can be disguised as a vertical asymptote there. So when that happens, we need to go ahead and actually determine what is your vertical asymptote, which one is your holes. And we're going to do that in this one. All right, so vertical asymptote, we're going to take a look at these three. Set denominator equal to 0. So let's do this part first. All right, so when we do this, there is a thing called the zero products principle, where we take each one of these factors and set them equal to 0. And you probably didn't know that's what it was called, but that's what it is, the zero product principle. All right, so we have x equals 0, we have x equals -3, and x equals 2. Now with this, like I told you guys already, oops, almost fell. Like I told you guys already, there's sometimes a vertical, a hole can look like a vertical asymptote because you're doing the same process as you would do for a vertical asymptote when you're doing it, but it actually ends up being a hole. Now, with this, because x plus 3 is on the numerator and the denominator right here, because both of them are, as one in the numerator, one denominator, they will be considered a hole because it's technically not a vertical asymptote, because technically you can cancel those out and you can actually do with the function without that being there. So technically in there, x cannot equal -3 because it'll make it a this function undefined on the denominator. So we put a -3 down here, like right there, we put -3. That'll be -3 plus 3, which is 0. And now, since we're multiplying, everything on the denominator will be equal to 0, and you can't have that. So technically, it's not a vertical asymptote, really, because, again, the two functions, the numerator and denominator has that factor in it. So I'm going to write this out. And this happens every time you have a hole. And let's do it a different color. So since the factors x plus 3 cancel in the numerator and cancel in the problem, x equals -3 is considered a hole. In the graph. So it's a hole in the graph. So again, if you can cancel the factor out in the numerator and denominator, that means it's considered a hole in the graph. So x minus 3 here, that's not a vertical asymptote, it's actually a hole. So again, if you can cancel out that factor in the numerator and denominator, that means that that x value is actually a hole in the graph. All right, so with that, be careful when you're doing this stuff. Don't just automatically say, oh, it's a vertical asymptote and be done, because it might not be. It might actually be a hole. All right, so let's go ahead and take a look at our horizontal asymptote now. All right, and with this, to make this as easy as possible, we're going to go ahead and do what we just talked about. We're going to cancel out the x plus 3's in it. So we're looking at the real function here, what's really going to be graphed out. All right, so we have this. And we're going to cancel out the x plus 3's because, again, that's a hole in the graph right there. So we don't need that part when we work it out. So technically, our function is this. Okay, so what will be best to do to be able to find our horizontal asymptote is to go ahead and multiply your denominator, distribute your denominator, distribute the x in the denominator, which will give us x squared minus 2x. So we distribute that. Okay, so now we can go ahead and find our the variable with the highest exponent, simplify it down, and do all this great stuff. So with that, the variable with the highest exponent is x squared. Okay, so since that's your variable with the highest exponent, it means we're going to divide every term here in that blue function or blue fraction there by x squared, every term. So I'm going to use the blue here to signify the original function, and then we're going to go ahead and go from there. So we're going to do x, and then plus 1 for your numerator. And we're going to divide everything by x squared. And again, remember, we are doing this only for the fraction. If there was a whole number back there like we had early on, we wouldn't do that. So we're dividing each term by x squared. All right, simplify it down. So here we get 1 over x. This gives us 1 over x squared. We get 1 here. And then 2 over x squared. 2 over x, sorry. 2 over x. All right, cool. So we said anything that has a fraction goes to 0. So this part we have 0 plus 0 over 1 plus 0. So technically we have 0 over 1, which is 0. So our horizontal asymptote is y equals 0. So we have 2 vertical asymptotes. We have 1 horizontal asymptote. We have a hole in the graph. And before we actually graph everything out now, let's go ahead and find out where that hole is before we actually do, so that when we graph it out, we can actually graph it accurately, or at least as accurate as possible. All right, so let's do this. Where is the hole? Where is the hole? Where is the hole? All right. So if we have an x value for the graph, and we have to actually figure out where the hole is. If you have the x value, you're trying to find your y value, so you have your ordered pair. So here, we're going to take a look at the function y equals, and we're going to break it down to the one that's simplified, that doesn't have the x minus 3 in it, or x plus 3 in it, because remember that will give us a 0, and we don't need 0. So we're going to come back to this function, because again, if we put in -3 in the original function, it will cancel things out, because it will give you a 0 in your numerator and your denominator, and you have 0 over 0, which is considered an indeterminate form, which you learn in calculus is a bad thing. So you have to do a thing called the L'Hopital's rule, but we're not in calculus right now. We're in pre-calc. All right, so with that, here we're going to go back to the simplified version, because again, if we put it into original, it will give us a term that we can't use. 0 over 0, that won't work. So here, we know the hole is at x equals -3. So we need to find out what is the y value that actually works for that, so that we can actually have the ordered pair xy for that hole. All right, so let's go and substitute -3 in here for x. And we can find that hole. All right, so we get -2 on top. We have 9 plus 6, which is 15. So -9 squared, -9 times -9 is, sorry, -3 plus -3 times -3 is positive 9. And then 2 times 3 is 6. So 9 plus 6 is 15. So our hole is at -3, -2/15. So we're going to do like a roundabout answer there. So it's going to be a little bit interesting, but it's going to be roundabout. It's not necessarily the exact place, because it has a fraction there. And it's not an easy fraction either. Not like 1/2 or 1/3. It's like -2/15. Yeah. All right, so we're good. We're good here. We will do good. All right, so let's go ahead and label our graphs here. 4, 6, 8, 10. So -2, -4, -6, -8, -10. 2, 4, 6, 8, 10. Again, label your graphs are important. Labeling it's very vital and very valuable. All right, we get that part. And 2, 4, 6, 8, 10. All right, so we have that labeled. The graph is labeled. And we go ahead and do all of our parts. So let's go ahead and do our vertical asymptote first. So vertical asymptote was at 0 and at x equals 2. So we have a vertical asymptote here at x equals 0 and a vertical asymptote at x equals 2. All right, we have a horizontal asymptote at y equals 0. So we put that here too. And then we have a hole at -3 and -2/15. So I'm going to just guesstimate here. That's somewhere around in here. Somewhere around in there. Yeah. So somewhere around in there. So it's less than 1, but greater than but between -1 and 0. So we know it's somewhere in there. All right, so let's go ahead and graph this out. And if you need to look at the calculator and actually do it, you can do that too. But we're going to go ahead and do this here. So on the inside, it comes like here. On this side, it comes this way. And on the left side, it does something a little weird. So it actually starts a little bit below the asymptote. It hits that, and then it goes above the asymptote. And I'm like, that part, I'm like, I don't know why it does that. I'm a little confused. So I'm still trying to figure out, like, why is it cross the asymptote when we actually said that the graph would never touch it? Math always does some weird stuff like this, but we have to figure out why. So our goal is going to be to figure out why this happens. So with that, this is the function here, and this is the graph of it. So we will figure out why this is happening. All right, so cool. All right, so that is the end of our rational functions. We have one more example, one more practice left, and then actually no, that's it. There's no more practices. That was it. That was the last one. So with that, go ahead and turn the practices in there on Canvas, upload them, and then we'll have homework. All right, let's go. Let's get this thing.